Welcome aboard to the part 2 of your physics revision for the CBSE 2026 board examination. So the part 2 of your NCRT, guys, the book number 2, that's what we're going to revise today with your captain Shreyas on the Vedantu JEE English channel, guys. Last lecture was part 1, which we had yesterday. Yes, we saw all the important questions, the entire revision of all the chapters from your book 1 of NCRT. So today we are going to continue with part 2. Also, just before that, I had conducted most important case studies in case you want to have a look at it. And let me remind you, if you want more revision lectures, it's all there on the home page. Just go down over here and you will see CBSE Physics. The entire playlist is ready for all of you with the strategy, with all the NCRT line by line, everything. All right, even the derivations are there. So in case you want to go through it, right? So let's begin with the class. Hello, in my camp, YouTube user 2912, Disan, Sanjit, welcome, Apollo, welcome, Srikar, welcome, Sweta, welcome everyone out here. Hi, Neeraj. Hi, Sunshine. Good evening. I hope I'm audible and visible to all of you. Uh, all right. So let's begin with the lecture. Here it comes. Okay. So let's start with ray optics first. The ray optics questions. By the way, you will be getting the PDF in the description box. I'm not sure if you have seen the older PDF. It comes like this. Okay. Some of you are asking it. I've asked them to put it up in the comments because some of you are not able to find it in the description box. So I think it should be there. Oh, why is it not put? Uh, okay, I'll make them add that in the description box. I think it has been missed. Okay, I'll get it added, guys. Okay, so it should be there in the description box. So all the notes, all the important points for all the chapters, I have put it up over here, something like this, so that you can browse through it. Okay, later on. All right, let's start with the questions coming up on your screen. First objective, then 1 mark, 2 mark, 3 mark questions. That's how we'll go. Okay. Yeah, I8 man. Good evening, Gungu. Hi, Prabhakaran. Good evening. Good evening. Hi, Senthil. Hi, Priyanka. All right. An astronomical telescope has a magnifying power of 10. The focal length of the eyepiece is 20. What is the focal length of the objective? All right. So, what is the formula for the magnifying power of a telescope in the normal situation? That magnifying power is the division of the focal lengths of objective and the eyepiece. So, as you can see, this is over here and the magnifying power is given to be 10. I think the focal length of the objective is asked. The focal length on the eyepiece is given to be 20. So FO will be 10 multiplied by 20, which is nothing but 200 centimeters. So that is the answer. Yes, FO by FE. Correct. Awesome. Great. Okay. So yes, ray optics is a very important high weightage chapter. And Nitesh, you have failed in the PCM English pre-boards. If I start now, can I score 95 plus? I have 4 marks in practicals, need 6 strategy. Nitesh, just go through the questions which I'm doing today plus yesterday and the case studies and the sample paper. Just do that much, you will pass at least if that is your scenario. Okay, because there are barely 2 days remaining. So obviously, just go through the marathons questions. Okay, that's what you can do the best. Don't go for higher mark questions, go for the lower mark questions. That will give you marks. Option C, correct. Yes, option C is the right answer. Moving on to the next one. Dielectric constant of mica is 6. What is the velocity of light in this medium approximately? How is dielectric constant related to the velocity of the light? Maybe it is related to the refractive index somehow or the other. Yes, if you remember, actually, the speed of light in electromagnetic waves chapter is given by 1 by permeability into permittivity. But if the permittivity changes, then you also have relative permittivity, which is also the dielectric constant of that medium. So this is speed of light in any medium. Now that is what we need to find. So Cm will be, if you take this particular term separately, 1 by root mu naught epsilon naught, this one over here is basically the dielectric constant. The dielectric constant, this Er is nothing but the dielectric constant. This particular term over here is nothing but the speed of light in vacuum, and this divided by that dielectric constant. The dielectric constant is 6 and the speed of light is 3 into 10 to the power 8. So solving this 3 divided by root 6, yep, how much are you going to get the answer as? 1.25, 1.2 into 10 to the power 8 or 3, guys? Come on, put it up in the chat box. C by root ER, very good. Come on, put up the answer in the chat box right away, right now, guys. What do you think the answer should be? Yep. 1.2? Yes, but 1.2 what? 1.2 into 10 to the power 8. 1.2 into 10 to the power 8 meters per second. That should be the answer. Yep, not B, guys. I think it should be C. Yeah, some of you said C. Yep, perfect. Option C is the right answer. Root 6, guys, it will be 2 point something. So 2 point something. So 3 by 2 point something will be 1.2. Roughly you can gauge it. So that is why the answer is 1.2. Okay, cool. Let's move on to the next one. If mu j represents refractive index when a light ray goes from medium I to medium J, then the product, I think I is missing somewhere here. This is what I should be. Yeah, if I mu j is refractive index when light goes from 1 to 2 or I to j, then the product 2 mu 1 into 3 mu 2 into 4 mu 3 is equal to. Okay, first of all, if I tell you I mu j can be written down as mu j divided by mu I. That is the generic expression. Okay, refractive index of glass with respect to air will be refractive index of glass by refractive index of air. That is how it works. So this entire product which is there, I can write it down as 2 mu 1 can be written down as mu 1 by mu 2 multiplied by 3 mu 2 can be written down as mu 2 divided by mu 3. Then 4 mu 3 can be written down as mu 3 divided by mu 4. As you can see very clearly, mu 2, mu 3 cancels. So what am I left with? Just mu 1 on the top and mu 4 below. So technically this is nothing but light going from 4 to 1. So this is 4 mu 1. So this is 4 mu 1, but it is not there in the options. But remember, this is also same as writing 1 divided by mu 4 divided by mu 1. So this will be 1 divided by, what is this, mu 4 by mu 1? If you go by this logic, yes, whatever comes on the numerator comes next. So 4 will come over here and 1 will come over here. So that is option C, as you can notice. Option C for Captain Shreyas. Got it? So it's just a play of mathematics, play of numbers, play of these terms. So manipulation was there. And if you know this formula, you can easily get the right answer. The magnifying power of an objective is 8. Magnifying power of the microscope is 32. The magnifying power of the eyepiece is how much? Now, the magnifying power of the microscope is given by the formula magnifying power of the eyepiece multiplied by the magnifying power of the objective. Now, the total magnifying power of the entire microscope is the product of these two magnifications. So, this is given already to be 32 and the magnification of the objective is given to be 8. Only the magnifying power of the eyepiece is asked. Magnifying power of the eyepiece is asked. So, naturally, it will be 32 divided by 8, which is the number 4. Again, C for Captain Shreyas. I don't know why all options are C. Okay, C on the rocks. Option C. Very good. Yeah. Sir, can I get 50 with both of my classes? I don't know how to answer that, man. See, I'll tell you something. These kind of questions are not valid because in the same class, so many students are there. There are some students who get very good marks, some students who do not get good marks. So it is up to you. The teacher is the same, the classroom is the same, the content, books, everything is there. I've been doing this. You have so many resources. It's up to you how much you want to absorb, how much you are putting your hard work, and how you are implementing it at the time of the examination. Your nervousness, your presence of mind, everything matters. So if you ask me, can I crack it in Sir, 2 3 days, can I get some decent percentages? Yes and no, both are the answers. So it's always, up to you, and it is possible if you do it the right way. Okay, right. Let's move on. Which of the following is not the case with the image formed by a concave lens? Let's imagine a concave lens. It may be erect or inverted. It may be magnified or diminished. It may be real or virtual. Real image may be between, is not the case. Is not real image may be between the pole and the focus or beyond the focus. Okay, real image may be between the pole and the focus or beyond the focus. Basically, anywhere real image. I think this is very straightforward. You can see which of the options is correct very easily rather than which of the options are not correct or vice versa. Up to you. Thank you so much, Chotu Badmas. Wow, what a name! Such a cute name you have. Sir, for physics boards, can I start with any section and do? Yeah, you can do that, man. That's not a problem. You can do one markers at the end. That's not an issue at all. Okay. B, C, D. People are confused. Come on, my dear warriors. Think carefully and answer this particular question. Which of the following is not the case? Just let me get my water and cup. 1 second. Hmm. For the theory, I have already made the videos. It's there on the home page. I just showed it to you, no? Right over here on the home page. These lectures are there, big, big lectures. Okay. So go to the home page and you will get it. Okay. It's there right over here. CBSE board preparation physics. Okay. Come on. Hmm. Yeah. Come on, guys. Where is my comments? Yeah. Huh. Hmm. From a concave lens, can you get a inverted image, guys? Ever? Is it possible? Which of the following is not the case? Can you get an inverted image? Because if you remember correctly, one ray to will go directly like this. Any other ray will go like that because it will always diverge. So whatever happens, you will probably get the image somewhere over here, right? So you will notice that the image will always end up being erect. Yes, so you can never ever get a inverted image as simple as that. So this is not possible only. The image may be magnified or diminished. Yes, all those things can be done. Okay, it may be real or virtual, maybe yes. Okay, the real image may be between the pole and the focus. So guys, the also the one more thing you should realize that the object might need not be always a real object. It might be a virtual object also. It's quite possible. So just imagine this. If this is your lens, okay, maybe there is a virtual object somewhere like this. There is a virtual object. This is your virtual object, and the rays go like this, and they formed a real image over here. So a real image can also be formed by using a concave lens. Keep that in mind. Using a virtual object. So D option is correct. A lot of people said it is not correct. So D option is correct, guys. So it may be erect or inverted. No, it will always be erect. Yeah. Okay. Moving on to the next one coming up on your screen. A person is standing before a concave mirror cannot see his image unless he is beyond the center of curvature. Why? Now, this kind of question, what will you do? You'll explain it by either ray diagram, all right, not just by formulas. So, when you are standing in front of a concave mirror and this is the center of curvature, this is the focal point. So what happens is that you cannot see your image unless you are beyond the center of curvature. What is the reason for that? If you remember, if your object is here, if the object is here, then where is the image formed? The image is formed after the reflection somewhere in between. Now this is basically a real image. This is basically a real image. Unless he is beyond the center of curvature, standing before a concave mirror cannot see his image unless he is beyond the center of curvature. Now, if you consider that same concave mirror, if you consider the same concave mirror, all right, and let's say you are somewhere over here. This is the object, maybe this is the focal point, maybe this is the center of curvature. Where is the image formed? The image formed is virtual, it is big, and all of that. This is a virtual image, isn't it? There is a virtual image which is being formed. Yeah. So from this, can you see that whenever a real and inverted image is formed, real image, for that you need a screen, you cannot see it directly. Okay, it's seen on a screen, so he cannot see it by himself. But if he's before the center of curvature, then he can see his image, which is direct and virtual, because of the manner in which the rays reflect. And that is also the exact application of a dentist mirror. A dentist mirror always uses a concave mirror, and the teeth is placed below the or between the pole and the focus, so that it is so near that an enlarged virtual erect image is formed of the tooth, so the dentist can see any cavities if present very clearly. That is the logic behind it. Okay, great. All right, all right, all right. I am so scared. Don't worry, man. Everything will go well. Sir, we miss you a lot. Why are you going to miss me a lot, man? I'm here only, Huh. All right. Moving on to the next question on your screen. For what angle of incidence the lateral shift produced by a parallel glass slab plate is maximum? Now, remember, whenever you have a glass slab and a ray enters, let's say like this, and then refracts, and then again comes out like that, there is a phenomena called as lateral shift. That lateral shift is this. This is that lateral shift. This is that lateral shift. So I want this lateral shift to be maximum. So in that case, what you need to do is, whatever slab you have, make sure that the ray is almost grazing to the surface, almost like, parallel to the surface. So then inside the medium, it goes at a critical angle, and when it comes out, almost comes out grazing outside. So it goes in like this and almost comes out grazing outside like that. And in that case, yeah, the ray was almost going like that. Now you will see it has been shifted by this much amount. This is the lateral shift, but this is not any lateral shift. This is the maximum lateral shift which is possible. So as you can see, in such a scenario, the angle of incidence is almost 90 degree. In this case, the angle of incidence was not 90 degree, it was something. There was a decent lateral shift. When you make it 90 degree, the lateral shift is maximum. And in fact, the lateral shift, if this is the thickness of that slab, the lateral shift is almost going to be the thickness of the slab itself. So that is what happens. So if you show this ray diagram, you will get full marks, guys, and you can explain it what is happening. Okay, is that clear, everyone? Awesome, 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 awesome. Great. Cool. Shall we go ahead to the next question then? All right, here it comes. What are optical fibers? Gives one of their uses. This was also there in your 10th standard, if I'm not wrong. All right, so similar question coming up on your screen again. So what are optical fibers? Basically, they are translucent materials. They are very thin rod-like structures which are long, and uh, uh, they allow light to pass through them. They are made of very high quality of materials, so that the light does not get absorbed and the light travels through that glass very effectively. They are used for optical fiber communication, yeah, telecommunication. Yeah. And yes, the material is of a very high refractive index, and they work on the principle of total internal reflection. So you can show an optical fiber like this. It's made of a very high refractive index, and it is thin, long, clear glass. So once the light enters the medium, it never is able to come out because of internal reflections happening, and it comes out only on the other side, on the other face. They are useful for optical fiber communication, especially in your internet communication, like your modem is connected to the main server or hub using this optical fiber cables only. Yes, optical fiber cables are also used in medical applications. Their medical applications would be where you want to see inside some cavity, inside some hole, inside some intestine, something like that. And then what happens, they send in one tube, and the light passes through the tube and enters the camera. So that tube can enter your mouth, and it can be twisted inside the intestine. That's okay. As long as the light is inside that optical fiber, it will just keep on reflecting and finally come inside the camera. So it is used for that medical applications also. It is called as endoscopy, if I'm not wrong. Let's see whether these things are mentioned. They are used in medical investigations, yes, to see inside stomach or intestine by a method called as endoscopy. Correct. They are also useful for optical fiber communication. They are also used in fancy lights. You must have seen those fancy pot lights where light comes from one side and goes on the other side, and the lights are seen on the ends of the optical fibers which are cut. So they are also used in some fancy lights as well. Okay, right. Yeah, perfect. All right. So they are thin, long, translucent. They do not absorb the light. They are very clear glass. They are having very high refractive index. They based on total internal reflection. If you mention all these points, you'll get full marks. It is a 2-mark question. Remember that you have to mention all these points. How the focal length of a lens change with the increase in the wavelength of light? Come on, very nice question. Yes, yes, endoscopy, man. Okay, okay, okay. Come on, my dear warriors. Answer this question quickly. How does the focal length of a lens change with the change in the wavelength of light? Now, this is based on the phenomena of dispersion, and we know that if you have a prism or anything, and if you pass white light inside of it, then it is the violet light which is deviated the most, whereas the red light, it is deviated the least. This clearly tells me red light, which has a large wavelength, has less deviation, which means it has less refractive index, whereas violet light, it has a very short wavelength, so it has more deviation, more delta. That means it has more refractive index. So shorter wavelengths have more refractive index, and vice versa. Longer wavelengths have lesser refractive index. So how does the focal length change? So for that, we need to go to the formula of focal length. Focal length is mu minus 1 into 1 by R1 minus 1 by R2. So if refractive index is more, focal length is also more. So from this, we can finally conclude that for more wavelengths, or I can say for higher wavelengths, for higher lambda, when the wavelength is big, then refractive index is less. Refractive index is less, and because refractive index is less, the focal length is also less. So length the focal length is less. So for bigger wavelengths, the focal length is smaller. For smaller wavelengths, the focal length is larger. Simple. Got it, everyone? Yeah, straightforward, understood, pakka. Shall we go ahead? Awesome. Let's go. Next question on your screen. There is a telescope whose objective focal length is 140, eyepiece focal length is 5. What is the magnifying power when the adjustment is normal, and second time the adjustment is for least distance of distinct vision? It's just based on the formulas, nothing more. So if you talk about normal adjustment, the magnifying power is nothing but FO by FE, and FO is nothing but 140, guys. FE is nothing but 5. So 140 divided by 5, how much is it? 28. So 28 is the answer. Simple. Oh, sorry, wait a minute. I made a mistake over here, I think. Sorry, guys. This was F. No, this was 1 by F. My bad. My bad. My bad. This was 1 by F. So what will happen is, if refractive index is less, what will happen? Focal length will be more. I made a mistake, blunder over here. That was 1 by F. My bad. The focal length is more. My bad. I'm just correcting it over here. This was 1 by F. So if mu is less, F is more. If mu is more, F is less. Okay. So this was 1 by F formula. Yeah. My bad. Yeah. Coming back to this now. Over here, I just saw your comments on the chats and then I realized I made that blunder. Anyways, least distance of distinct vision. So in that case, remember what is the formula, guys? When it is the situation of a least distance of distinct vision? Yeah, correct. Yes, yes, 1 by F, Sanjit. Yes, I changed it. What is the formula? Then the formula is FO by FE, and the eyepiece is at least distance of distinct vision. So 1 plus 1 plus 1 plus, there is Fe by D over here. Yeah, 1 plus Fe by D. That's it. That is the change in the formula. So FO by Fe is still the same. So 140 by 5. And over here, 1 plus Fe, which is 5, the least distance of distinct vision is 25. That's it. So this is 28 multiplied by 5 by 25 is 1 by 5 over here. Yeah, so 1 by 5 plus 1. 1 by 5 plus 1 is nothing but 6 divided by 5. So that's it. So 28 multiplied by 6 divided by 5 will be the answer. So 28 multiplied by 6 divided by 5. Just check it out. How much are you getting it as? 28 into 6, whole thing divided by 5. Bro, you will be blocked. Who is this? Don't spam. Don't spam like this, man. Yeah. Don't spam like this. 28 multiplied by 6 divided by 5. Come on, my dear warriors. What is the answer? Yeah. Sir, will we be given all constants? It depends when sometimes they might give also, they might not give. So better to remember all the constants. It is expected that you remember all the constants. Yes. How much is this coming out to be? 28 into 5, 140, 140 plus 28, 168 divided by 5 divided by 5. 168 divided by 5. Just check it out. How much will it be? 3 is 3 is 33. 33.6. Just check it out. 33.6. 33.6 is the final answer. Everyone? Yeah, that should be the final answer. All right. Yes, one is 28, one is, yeah, 33.6. Perfect. There you go. So this is how questions can come from your ray optics. Let's go to some wave optics questions coming up on your screen. Now, here is the first question on your screen. The first maxima is closest of which color? Violet, red, blue, or green? Come on. First maxima is closest for which color, my dear warriors? What do you mean by that? See, you remember that the fringe pattern on the screen depends on the wavelength. There is a formula. Fringe width is lambda capital D by small d. So, on the screen, what you are going to see is the 0th maxima and then the first maxima. The distance between them is the fringe width. So it will be the closest. That means beta is small. So if beta is small, that means lambda is small. Now whose lambda is small? Obviously, it's the violet colors. So the violet has the smallest wavelength, and that is why lambda is smaller, beta is smaller. So the first fringe is the closest to the 0th maxima. As simple as that. Moving on to the next one. In a YDSE setup, the angular width is 0.2 degree for the sodium light. Okay, in order to increase angular width by 10%, the necessary change in the wavelength is how much? Well, what is the formula for angular width of the fringe? The angular width of the fringe, just like you have lambda d by d, here it is just lambda by small d, meaning it is just proportional to lambda. Now, it is clearly mentioned for sodium light, the angular fringe width is 0.2 degrees. In order to increase the width by 10%, the necessary change in wavelength is. So, since this is proportional to lambda, so it is very obvious now that if this has to be increased by 10%, then I will also have to change this by 10%. So because they are directly proportional to each other. If this changes by 5%, this will be 5%. This decreases by 7%, this will also decrease by 7%. So proportional relationship. So both of them will have to increase by the same amounts of percentage. So if my original wavelength is 5890, so the change, so if my initial lambda is given to be 5890, the change in lambda, which is 10% of this, which is obviously 589 angstroms, that is exactly your 10%. 10% means 1/10, you just remove 1 0, so it has to be increased by 589 angstroms. Yeah, option D. No, not 6479, guys, it is 589 angstroms. Cool. Option D. How many of you got it? Pranav got it. Yes. In me camp. Yes, it is option D. Yes, Edito. Yeah. Very good. Very good. Very good. Very good. Perfect. Yeah, beta by D is the same thing, guys. Beta is lambda D by small d. So when you divide it by capital D, it will cancel and only small d will remain. It's one and the same thing. Okay. Moving on to the next question on your screen. The condition for obtaining secondary maxima in diffraction pattern due to single slit is for obtaining secondary maximas, meaning just maxima. So for minima, what is the formula? For minima, what is the formula? A sine theta is equal to n lambda, isn't it? So that is for minima. But for maxima, the formula is A sine theta. A sine theta is odd multiple of lambda by 2. Yes, 2n minus 1 into lambda by 2, isn't it? That is the formula. So where do you see such a formula, guys? It is there as option number B. No, not this. This n lambda is for minima. For minima. Keep that in mind. For maxima, it is this. This is diffraction pattern, not YDSE, not double slit experiment, single slit experiment, diffraction pattern. The formulas are slightly different. This is the slit width, is the slit width, not the distance between the slits. Okay. Ideally, this should be 2n plus 1, but it's okay. You can say that my n will start from a higher number. That's okay, guys. It's not like it should be always 2n plus 1 or 2n minus 1. Basically, it should be an odd number. That is the whole point. Some of you might argue, sir, I think it was 2n plus 1. That's okay. But anyways, 2n minus 1 or 2n plus 1 will be odd number depending on how you start your n with, whether you start it with 0 or whether you started with 1. Okay. In a single slit diffraction experiment, the width of the slit is made double its original width. Then the central maxima of the diffraction pattern will become narrower and fainter, narrower and brighter, broader and fainter, broader and brighter. What do you think is the answer? Come on, my dear warriors. What do you think is the answer for this particular question? Yeah. So the fringe width is given by lambda d divided by a 2 times. That is the central maxima width. The central maxima width is 2 lambda d by a. So in this particular question, what have you made? The slit is made double its size. Slit is made double its size. So what will happen to the width? So width will also double. So the width will double. That means it will 100% be broader, not narrower. Now, whether it will become fainter or whether it will become brighter, obviously the slit will become wider, more light will pass through it. So the central maxima will obviously become more brighter. So hence it will become broader, as well as brighter. As simple as that. That is option number D. Yes, white gaming. That is absolutely the right answer, man. Okay, not B. Narrower is not the correct one. So if, oh, sorry. 1 second, 1 second, 1 second, 1 second, 1 second. What did I just do? It is not directly related. 1 second, guys. If the slit is made double, this denominator will increase. If denominator increases, the ratio will decrease. My bad. The ratio will decrease. My bad. Yeah, the ratio will decrease. So the slit width, if it is increased, the width on the screen of the central maxima will reduce. So it will become obviously narrower, not broader. My bad. But will it now become fainter or will it become brighter? Now, because you have increased the slit width, more light is passing through that, more energy is passing through that. So now all of that light will be concentrated on a narrow fringe. So yes, that fringe will become more brighter anyways, because anyways more light is passing through that slit. So it is option B, guys, not option C or D. My bad. Okay, so just changing it to option B. My bad, not D. Yeah. So A increases, W decreases. W decreases means narrower. Second thing, when more light passes through that slit, more energy is passing, and now it has to be concentrated on a narrower area on the screen. So yes, it will be more intense and more bright. Okay, perfect. All right. Let's move to the next question. If there is a diffraction pattern, when you use yellow light, now yellow light is replaced by X-rays, then the central maxima will become what? Now the width of the central maxima, I just told you, it is 2 lambda d divided by A. So if you compare yellow light versus X-rays, X-rays is very small. X-rays has a very small wavelength. This is yellow wavelength. So when you are using X-rays, the wavelength is reducing drastically. So the width on the screen of the central maxima will also become smaller, becomes narrower. No change, none of these. The answer is it becomes narrower. Option B. Correct. Yeah. Yeah. Awesome. Yeah. Who is that? Angel Jane? No, the intensity will not reduce, man. In the previous question, it will increase because more light is passing now. Okay. Keep that in mind. Earlier, the slit was this wide. Now we have made it double. So more light is passing. Now where that light will go, it will fall on the maxima. So obviously more light being concentrated on the maxima means it will become brighter. Okay. Right. Perfect. Let's go to the next question on your screen. Draw the diagram to show cylindrical wavefronts. There are three kinds of wavefronts. One is spherical, one is cylindrical, one is planar. So here they are cylindrical. So cylindrical wavefronts are produced by cylindrical or linear sources, line sources. They produce cylindrical wavefronts. The rays of light will go in all the directions in that same plane, not on the faces, not on the circular faces, only on the curved surface. That is the wavefront, and the wavefront keeps on expanding. The wavefront keeps on expanding. So after some time, the new wavefront will be this big. Height will not change. Then it will become this big in radius. So the wavefront keeps on expanding as the rays propagate. For a spherical source or a point source, the wavefronts are spherical in nature. And for a planar source, the wavefronts are also again planar in nature. They go in parallel planes. So these are the only types of sources and wavefronts which you should be aware of in light waves. Is that right? Okay. Perfecto. Sir, is the intensity of the central maxima is the same as the source in Young's double slit? No, it is not the same for diffraction. That is the main difference between Young's double slit and single slit diffraction. So in case of YDSE, what happens is the intensities are the same. Intensities of all the maximas are same. But in case of your single slit diffraction, only the central maxima has the highest intensity. The other maximas have lower and lower intensities. They are hardly even visible. So this is how the intensity changes in single slit diffraction. Okay, that is a major difference of the maxima minima fringe pattern. So in a double slit experiment, you will see bright, dark, bright, dark, bright, dark, bright, dark. All the brights are equally bright. But in diffraction, only the one at the center is very bright. The ones besides that are very faintly bright, and after few fringes, they are hardly even seen. Okay, is that clear? All right, perfect. Let's go to the next question on your screen. A light wave enters from air to glass. How will the following be affected? Air to glass. Energy of the wave, frequency of the wave. I think answers are given. Energy of the wave, frequency of the wave. Yes, frequency never ever will change. Remember, whether you change the medium or not, frequency is always decided by the source. So since it is coming from the same source, the rate at which the oscillations occur will still be the same. Speed of light will change. Because of that, the wavelength will change. But you will not see that the frequency will change. Make sense, guys? Yeah, frequency will not change. But what about the energy? Yes, when light goes from air to glass or changes medium, some energy will get reflected back, some energy will get absorbed, some energy will be transmitted. So the transmitted energy is always going to be lesser than what is incident. If 100 joules of energy was falling, 2 joules might get reflected, 3 joules might get absorbed, and the remaining 95 joules might get passed on inside the glass. So obviously energy is lesser as compared to the incident energy. Okay, it will definitely change. Okay. Dark fringe also differ. Dark fringes are dark only. It's not like it will be more darker. Darker is, that's it. It's dark meaning you see nothing. Seeing nothing is called dark. So you will see dark fringes, both in YDSE also, single slit also, but the contrast ratio will be different. Okay, think of it like that. Just to give you more clarity on this, if I had to literally shade it properly, this is YDSE fringes. But if you go for single slit fringes, it will be like this. I don't know whether you are able to see the difference. Yeah, this is in the case of single slit. This is diffraction. This is double slit. This is interference. Now, what happens after some time? You will hardly be able to see the bright fringes, so the contrast will go away. So the dark is that dark only, but you are not able to see it with respect to the bright fringe because hardly any difference is there. But here, the difference between the bright and dark is contrasting. Is it now clear, guys? Pakka? Okay. So Yuga Shelvan, sir, but energy is given as a function of frequency. Very correct. Perfectly right. But in the energy formula, even the amplitude comes. In fact, it is proportional to the square of amplitude. So when light enters from one medium to the other medium, where was that question? This medium. Uh, Remember, the amplitude will not be constant. Amplitude will change when medium changes. So inside the glass, you will see a very less amplitude as compared to one in air. So you will see the energy will be much lesser. Okay, is that making sense, man? Yes. So in a single slit in cam, the color will fade, and after forget three fringes, even after two, three fringes only, you will barely see anything. Here, though, I showed it very bright, but actually in reality, when you see, right, even the second or third is also barely seen. It is not even, you have to literally see it properly to identify the second and the third fringe. So hardly any fringes are seen in the diffraction pattern. So 4/5, it's as good as dark only. Okay. All right. Perfect. Yeah. Awesome. Awesome. So just remember one thing, more the slit width, more is the intensity. Just remember that. Simple reason. Okay. More slit width means more light passes. More light passes means more intensity. Okay. But the actual formula is quite complex. It comes weird. Okay. It's not so simple. It is a very weird thing. It's not there for your CBSE level, not even for JEE Mains, man. Don't waste your time on that. All right. So obtain the expression for ratio of intensities at maxima and minima in an interference pattern. In an interference pattern, what is the ratio of the intensity at maxima and minima? So when you are talking about maxima, I max, that will be some constant multiplied by the maximum amplitude square. And I know intensities are always proportional to the square of the amplitude. So, okay, maxima expression of, okay, this is one thing. But remember one thing, we can give the answer in terms of intensity also and amplitude also. It's completely up to us. So this will be nothing but constant. Maximum amplitude will be A1 plus A2, constructive interference. So this is because of constructive interference. This is because of constructive interference. Now similarly, the minimum intensity will be constant multiplied by A minimum square, and that minimum intensity will be A1 minus A2, the difference of the amplitude because of destructive interference. Destructive interference. So now if somebody decides to take the ratio of Imax divided by Imin, that constant will anyways get cancelled. So if you want, you can put it constant and constant, not an issue. This will be A1 plus A2 whole square, and this will be A1 minus A2 whole square. Constant will cancel, so it will become A1 plus A2 divided by A1 minus A2, and this whole thing square. So this is the answer for the ratio of the intensities of maxima and minima in the interference pattern in terms of amplitude. But if you don't want to give it in terms of amplitude, then here is the logic. We all know intensities are proportional to the amplitude squares. So I1 will be constant multiplied by A1 square. So therefore A1 will be I1's root divided by root of constant, which is basically root I1 divided by a new constant, I can say. So similarly, I can say A2 will be root of I2 divided by some new constant, because root of a constant is also a constant. So if you do that part over here, you will see A1 plus A2 means it will be nothing but root I1 by some constant plus root I2 by some constant, whole thing divided by root I1 by some constant plus root I1 I2 divided by some constant. This whole thing square, constants will get cancelled, and I'll have root I1 plus root I2 divided by root I1 minus root I2, the whole square. So this is another way of writing the same thing, because intensity is proportional to the square of amplitude. That's all. Okay, perfect, awesome. That formula which you see, which many of you might have seen, sir, intensity at any point is 4I cos square, your phi divided by 2. Okay, cos square phi by 2. Yes, have you uh, seen that formula? 4I cos square, sometimes theta by 2 also they put. That's fine. So in that, do you know what is this intensity and what is this intensity? This is intensity on the screen. Intensity at a point on the screen. At a point on the screen. This I is intensity due to one of the slits. Intensity due to one of the slits on this one of the slits, any one slit, either this slit or that slit. So if you have two slits, if you cover one slit, only because of one slit, how much intensity is coming, that is I. Got it? So this formula, you can use it for finding the intensity at any point on the screen. Yes, this can also give me maximum and minimum intensities, but provided both the slits have same intensity. So this is a very special formula, but what I showed you over here is a generic formula which is more applicable, because sometimes one slit might be more intense than the other slit. So in that case, you cannot use that special formula. You are bound to use this formula. Root I1 plus root I2 upon root I1 minus root I2 whole square. Yeah. All right. Perfect. Okay. Okay. Is that clear, Hemant Krishna? Oh, this is what I asked before. Okay, I hope this is clear. First, fringe changes as different wavelength color used. Can you explain about the color pattern that we can see? So, somebody asked that question. Let me explain that also. Since you guys have some questions, it's okay, guys. It's not like I have to complete something over here. If some doubts are coming, tomorrow exam is there. It's okay. You guys can ask those doubts. It's fine. So remember our fringe width beta is lambda capital D divided by small d. Now, if I just talk about what you will see on the screen, these are your slits S1 and S2. This is the point directly opposite that. So if you are using a red color light, if you are using a red color light, wavelength is higher, fringe width is higher. So you might see a big fringe over here, big gap, and then a big fringe over here, big gap, and a big fringe over here. Okay. Now, if you use, let's say, maybe violet color light, then the fringe width will be very small. The gap will be also less, and that's why the next fringe will be closer. Next fringe will be closer, like that, over here, like this, maybe. If you use, let's say, yellow color light, the fringe width is between blue and red. So the fringe will be medium wide, and maybe you will see that fringe getting repeated somewhere over here, and maybe like this. So you will see that the fringe pattern never truly repeats again, because this is the only place where all maximas are together. All colors maxima together. So when you mix back all the colors, you will see basically white color fringe at the middle. And because red is the biggest fringe, violet is the smallest fringe. So the central part is white because all colors are mixing back again. Because nowhere else you will see their mixing happening together again, no matter where you go, because there are infinite colors. It's not just red, yellow, and blue. There are so many colors in between them. They will never mix back again. So after you go back over here, you will see that the fringe will slowly have different shades of red, yellow, and blue. So you will see some colorful pattern on the screen, but the white fringe will be there only at the center. You will not see perfect dark anywhere because somebody's maxima will be always there, or somebody's medium shade or medium brightness will be always there. So you will not see a perfect dark as per say, but you will always see some kind of colorful pattern on the screen. Okay, is this clear? Yeah. Hmm. Guys, don't take so much tension, man, because I know the maths paper was difficult for 10th board examination, class 10 CBSE. So it is quite expected that one of your papers might be tough. Now, I don't know why they made maths paper tough and why uh, any other paper might be related to that for your 12th standard. So it's quite possible that if they are following a similar kind of guideline or strategy, maybe physics or maybe maths could be tough. So be mentally prepared for it. If physics is not tough, then expect maths could be tough. If maths is not tough, then expect physics could be tough. Okay, so uh, that's what at least the feedback was from the 10th standard students who gave the maths exam. If you know, it was there in the news lately. Yeah. Yes. Yes. Yeah. Yeah. Yes. So last year CBSE physics paper was tough, and actually one set was very tough. Let me tell you that. So it is expected that similar things can happen. Similar things can happen. All right. Okay. Let's talk about the next question. In Young's double slit experiment, how is the fringe width going to change when light of smaller frequency is used? Distance between the slits is decreased. Smaller frequency. Okay. So what's the formula for fringe width? It is lambda d divided by d. Now lambda f is equal to speed of light. So c by f is lambda. So this is the formula. So if you notice over here, Now the fringe width change when light of smaller frequency is used. If you use light of smaller frequency, then the fringe width obviously will increase. The fringe width will obviously increase. So light of smaller frequency, if it is used, then the fringe width will definitely increase. You can see frequency is there in the denominator. Similarly, distance between the slits is decreased. Distance between the slits, if you decrease it, then naturally beta will again increase. So for this also, the fringe width will increase only. Yeah, both the cases it will increase. Perfect. Perfect. Cool, guys. Shall we go ahead? Yeah? Akka? All right. Let's move to the next question. In YDSE experiment, the slits are repeated at 0.24 millimeters. That means distance between the slits. The screen is so many meters away. The fringe width is also given. Calculate the wavelength. So this is a straightforward experiment, guys. Sometimes they can also tell that the entire setup was dipped inside a medium of refractive index 1.5 or 1.6. So in that case, the wavelength will change. So be careful. Wavelength of light in any particular medium is wavelength of light in air divided by refractive index. In this scenario, it was not dipped anywhere, so the wavelength will remain the same. But I'm just giving you a possible scenario which can make the question difficult. So in this case, just use beta is equal to lambda capital D divided by small d. And calculate the wavelength of light they have asked. So lambda will be nothing but beta D by capital D. Fringe width is already mentioned as 0.3 centimeter. So into 10 to the power minus 2. Small d is 0.24. So 0.24 into 10 to the power minus 3. And the whole thing divided by 1.2 over here. Come on, my dear warriors. How much are you getting? And the answer as, yeah, 24 and 12 goes 2 times. 2 3s are 6. So 6 into something will be there. Now tell me 6 into which power is there? Wavelength. Lambda is 6 into which power of 10? Come on, my dear warriors. 6 into 600 nanometers. That means 6 into 10 to the power minus 7 meters, which is 600 into 10 to the power minus 9 meters, which is 600 nanometers. Yes, check this out. If you are getting 600 nanometers, my dear warriors, very good. Sanjit, Audito, Akhurna. All right. Okay, perfect, man. Cool. So let's go then to the next question. Okay, that was a wave optics last question. Dual nature of radiation and matter. Let's go to question number 1. Theory slides have been put over here, guys, for your revision. I will try to upload it as soon as possible, as soon as the lecture is over. In a photoelectric experiment, the voltage versus current graph is plotted. Then A and B will have different intensity, B and C will have different intensity, A and B will have different intensity, A and B will have equal intensity, B and C will have different. Okay, come on, figure this out. Okay, in a photoelectric experiment, what can you comment in this particular scenario? Just look at the graph and answer. Yeah. Which unit is preferred? Prefer standard powers like micrometer, millimeter, nanometer, picometer, femtometer. So prefer nanometers, but put the answer in both powers, in meters also and nanometers, because sometimes these examiners know they act very weird. See, in their model answer sheet, if it is given in nanometers, so even if you get 6 into 10 to the power minus 10 meters, just imagine the stress the teachers are under. It's not that teacher has the bad intention, but they are correcting thousands of papers. Okay, so they will not use their brain so much. That 6 into 10 to the power minus 7, is it same as 600 into 10 to the power minus 9? Do you think they will think so much for every single question, for every single student? I am not sure. Of B is higher than saturation current of A. That means intensity of B is more than intensity of A, because intensity and currents are directly proportional. So A and B will not have equal intensities, they will have different intensities. So A and B will have different intensities, A and B will have different intensities. Whereas B and C will have different frequencies, A and C will have different frequencies. Because you can see over here, this point and this point, that is stopping potential. So stopping potential, V stop, depends on the frequency. depends on the frequency. So the stopping potential of A and B is same. You can see they are meeting over here. So frequency of A and frequency of B will be same, but it will not be the same as frequency of C. So A and C will have different frequencies. So B and C or A and C will have different frequencies. So B and C will have different frequencies. So that means option A is the right answer. Got it? How we got it? Everyone? Awesome. That is how you should dissect a graph. Okay. So please don't take objective questions of or MCQ questions of CBSE very lightly, because when you're writing JEE exam, you think, CBSE or MCQs, I'll do it. No, it might not be 10 minutes or 5 minutes that you take for solving all the objective questions. Sometimes you might take even 15 minutes or even 17 minutes or 18 minutes to solve all the objective questions, because you have to think for every single objective question. So don't take it very lightly, guys. I'm telling you now only, because CBSE is known to give surprises. And if they have given maths paper difficult, I am predicting either physics or maths of 12th standard will be difficult. Maybe not all the sets, but at least some sets. The work function of aluminum is so and so. Two photons of 3.5 electron volt strike an electron of aluminum, then the emission of electrons will be possible, will not be possible. Data is incomplete, depends on the density of the surface. Work function is given. Energy of the photon is given. What do you think, guys? Guys, the energy of the photon is less than the work function. So no photoelectric effect will happen. So will not happen. B option. Perfect. Yeah, no matter what you do, you will not get any kind of photoelectric effect. Next one. Photons of energy 1 electron volt and 2 electron volt are successively incident on metallic surface whose work function is 0.5 electron volt. The ratio of the kinetic energy of the most energetic photoelectrons in both the cases will be in what ratio? So you will take some time to solve. It's not like 10-second question. So photon energy is 1 electron volt. The work function is given to be 0.5 electron volt. In the first case, I'll get some kinetic energy. So that kinetic energy K1 will be 1 minus 0.5, which is basically 0.5 electron volt. In the second case, the photon's energy is 2 electron volt. The work function is still 0.5 electron volt. Kinetic energy is K2. So therefore, my K2 will be 2 minus 0.5, which is 1.5 electron volt. Now the question is, what is K1 by K2? K1 by K2 is 0.5 divided by 1.5. So that will be 5 by 15, which is 1 by 3. So 1 by 3 is C option for Captain Shreyas. Absolutely the right answer. Not B option. It is C option, man. Very good, Gugun, Hemant, in my camp. Tejasvi, awesome, awesome. Akurthan, Durai, awesome, 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 man. Perfecto. Moving on to the next question on your screen. The phenomena which can be explained only by quantum nature of light, not wave nature. Quantum nature means the light energy is going in packets, not continuously. Photoelectric effect, reflection, interference, polarization. Polarization of light is an electromagnetic wave phenomena. Transverse waves can only undergo polarization, so it's a wave phenomena. Interference is also a wave phenomena. Reflection is also explained by Huygens principle of reflection, wave formation and all of that. So Huygens wave theory basically. Photoelectric effect given by Einstein, for which he won Nobel Prize, is the phenomena which predicts that light is also showing quantum behavior, particle-like behavior. Sir, it is Gungun, not Gugun. Oh, sorry, man. The thing is, your names are so small for me over here. My computer screen here, I am here. So I try to pronounce the names as far as possible accurately, but sometimes these slips happen. Okay, so don't mind. In the photoelectric effect, electrons are emitted at a rate that is proportional to amplitude with maximum velocity proportional to frequency at a rate independent of the emitter only if the frequency of incident radiation is above a certain threshold value. In a photoelectric effect, electrons are emitted. So electrons which come out from that surface, what can you talk about it? At the rate that is proportional to the amplitude of the radiation. with a maximum velocity proportional to the frequency of the radiation at a rate that is independent of the emitter only if the frequency of the incident radiation is above the threshold value. So I think this is what the right answer is. If the frequency is more than threshold frequency, only then, yes, photoelectric effect will occur and you will see electrons coming out of it. So if electrons are emitted only if the frequency is above that threshold frequency. Yeah. Okay. Can you explain polarization in chapter 2 of dielectric medium? All right, just let me complete this and then maybe I can explain dielectric medium. Okay, so objective questions are done. Just 1 second, I'll explain you. So somebody is asking, sir, can you please explain polarization in dielectric medium of electrostatics chapter? So I'll just tell you what it is. So let's say there is a medium over here. There is a medium over here. Chumma. Imagine it is made of some polar molecules. Polar molecules like hydrogen chloride, H2O, NaCl, salt, some crystal. Just imagine like that. So what will happen in that medium? So it will have some positive charge, positive charge, positive charge, positive charge, positive, 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 and negative charge. So negative charge here, 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 charge here, negative charge here. Now I'm showing it randomly. Reason being, you can see these are all small dipoles which are formed. Like negative to positive is a dipole like this. Negative to positive is a dipole like this. There is a dipole moment here. 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 So you can see dipole moments being formed. So can I say that the net dipole moment is equal to 0 due to the randomness and cancelling nature. They are cancelling out each other. Yes, they are randomly oriented and they are cancelling out each other. And what is this scenario? When there is no external field, when there is no external electric field. Now imagine that same solid, okay, imagine that same non-conducting medium which has some polarities. Okay, but now external electric field has been applied. Okay, you have applied some external electric field like this. This is the external field. This is your external field which has been applied. What will the external field do? On the positive charge, it will apply the force in the direction of the field. On the negative charge, it will apply the force opposite to the field. So you will see all the positives moving towards the positive, towards the electric field, and the negatives opposite to the electric field like this. So there is an alignment which is happening and you can see that alignment very clearly now. This is positive being pulled towards that electric field like this, like this, like this, like this, like this, like this. So the dipoles are now arranged. So the dipoles are in the direction of external field. Okay, so they are in the direction means they are reorient themselves. So because of that, what will happen, guys? Imagine if there is a dipole which is like this. If this is a dipole, when I said this is a dipole, that means this is positive, this is negative. Then the electric field, because of the dipole, how will it come? The electric field because of the dipole, it will go like this and go like that. Yeah, it will go like this and go like this. So can you see the dipole, if it is oriented towards your right hand side, the field by the dipole is exactly opposite to it. So when the dipoles are oriented in this way, which direction will the field be? Obviously, the field will be in this direction. The field will be in exactly opposite direction, guys. It will be in exactly opposite direction. So this is basically induced field due to polarization. Due to polarization. Polarization means There are two poles which are separated by some distance. So these are dipoles. So that is that polarization which is happening, and that is why the induced field is opposite to the dipoles by this logic, and it is opposing the external field. That is why the net electric field, the net electric field will be your external field, will be your external field, will be your external field minus the induced field, minus the induced field. So that is why it is less. So that is why the force also reduces k number of times. Is that okay? Everyone? Pakka? Clear about this? All right. All right. Calculate the energy associated in electron volt with a photon of wavelength 4000 Angstrom. Guys, there is a direct formula instead of using hc by lambda. Yes, you can use hc by lambda, or you can use 12400 because this answer will be in joules. 12400 by lambda, provided this wavelength is in Angstrom, and the final answer you will get is EV. Here the answer you get is in joules because the wavelength is in meters. Okay, so that is the formula. If you remember, you can get the answer directly. So 12400 divided by wavelength is 4000. Okay, two zeros will cancel. So 124 divided by 40. So 124 divided by 40. So that will be nothing but 31. So 3.1 electron volt. So 3.1 electron volt should be the answer. Everyone? I'm so glad, Hemant, you understood it. Yeah, no problem, man. Hey, don't spam, man, like this. Chemistry, tomorrow you will get one strategy session. First, how to prepare for those days, and then you will get the sessions after that. Okay, cool. Shall we go to the next question? All right, moving on to the next question on your screen. Mention one physical process for the release of electron from the surface of a metal. Now, this is 1 mark. If the same question comes for 2 marks, they will explain. They'll ask you to explain the 3 processes through which an electron can come out. So, any one process, the answer will be photoelectric emission. But if they ask you more processes, then one more answer will be thermionic emission and field emission. So, in photoelectric emission, we know light falls, electron comes. In thermionic emission, you heat the metal, electron ejects out due to the thermal energy. That is thermionic, second number. Third number is field emission, meaning you apply a very strong electric field or create a very strong voltage difference between the plates. So that field pulls that electron out of the metal. So the electron emitted is then called to be emitted because of field emission, electric field emission. So these are the 3 ways. This is a 1 mark question, but I have told you how it can even come for 2 mark question also. Okay, keep these things in mind, guys. Derive an expression for De-Broglie wavelength of an electron. So see, in the previous question when I told you, right, these emissions, these are there at the initial parts. Usually people focus on the main parts, but CBSE can ask you suddenly a question from the intro paragraph, suddenly from the summary, suddenly from the last paragraph, somewhere from the in-text, somewhere there is a box somewhere, and in that they have mentioned some information. They will ask you a question on that. Like for example, that microwave example is there in a box, so they can ask you a question from there. This thermionic emission and all is there in the first few lines. Okay, so you need to know NCERT properly, guys. Derive an expression for the De-Broglie wavelength of an electron. So De-Broglie wavelength of an electron, lambda is Planck constant by momentum, you can say. So this is De-Broglie's expression, but do not end over there. That is not what they are expecting. If you write this, you will get 0 marks. Okay, you will get 0 marks. So now what you will write for an electron, actually for an electron accelerated through a potential difference should have been mentioned, accelerated through a potential difference. That is what they should have mentioned it. So here that momentum is root of 2 times of m times of energy, and that energy, my dear warriors, that energy, my dear warriors, is the kinetic energy which will come from electrical potential energy difference. So charge multiplied by voltage, that is what you will write. Now you will put h over here as 6.6 into 10 to the power minus 34. Then over here 2 times of mass. Mass is 9.1 into 10 to the power minus 31. Charge is 1.6 into 10 to the power minus 16. And lastly, over here, 1 by root delta V. Whatever answer you will get will be in meters, by the way. Yes, this will be in meters. But you want the answer to come out in nanometers. So for that, only you multiply whatever number is there as 10 to the power 9. So you can also then write 10 to the power minus 9 deliberately over here. By the way, by this, you are still getting the answer in meters only. Now, when you calculate all these numbers and you also multiply 10 to the power 9, the number that you finally get is 1.227. This root delta V will be there, and 1 of the 10 to the power minus 9 is still remaining, and this is in meters. But 10 to the power minus 9 is nano, so this will become 1.227 by root of delta V. This is nanometers. That is how you should write down the steps. You will get full 1 mark or 2 marks. Understood? Got it? Yeah. This is how answers have to be written, man. All right. Perfect. Let's move to the next question on your screen. Light of wavelength 2000 falls on aluminium. Aluminium 4.2 electron volt is required to remove the electron, meaning that is the work function. What is the kinetic energy of fastest? The slowest. Slowest is very obvious, guys. The slowest photoelectron will have lost all energy, lost all of its energy. So that's why the energy will be 0 electron volt. That is very obvious. In fact, all the electrons have different energies. Slowest will be 0. Highest you can calculate using Einstein's equation, which says energy of the photon is work function plus maximum kinetic energy of that photoelectron. Keep that in mind. Yeah. Okay. Mohit, if you got 94.78, most likely you are eligible, man, for JEE Advanced. So you can start preparing for JEE Advanced simultaneously. Yes, you are 99.99999% you are eligible for advanced. Okay, unless something crazy happens in the April attempt and but still you are 94 percentile, they will consider the best of the best scores. So yeah, you should be able to write JEE Advanced. So don't worry about it. Yeah. So energy of the photon, this is 2000 Armstrong, right? So 12400 by wavelength, which is 2000, but this is an electron volt. Work function is 4.2 electron volt plus K max. So from this, you will get the value of K max, guys. So two zeros cancel. So 124 divided by 20 electron volt minus 4.2 electron volt. So how much is your maximum kinetic energy going to be, guys? Yeah, come on. Yes, how much is it coming out to be? This will be 124 by 2, 62. So 6.2, 6.2 minus 4.2, that is 2 electron volt. So maximum is 2, minimum is 0. Any energy in between that is possible. More than that is not possible. Yeah, okay. Is there any condition for using HC as 12400? So the logic goes as follows, man. Energy of a photon is 6.6 into 10 to the power minus 34 into speed of light, which is 3 into 10 to the power 8. Okay, this whole thing divided by wavelength. Whatever answer you get in such a scenario will be in joules, and this wavelength will be in meters. Okay, the answer will you get in joules, this wavelength will be in meters. This is hc by lambda formula, right? This much part is h, this much part is c. But if you use 12400 by lambda, or if you use 1240 by lambda, then what is the logic? This should be in Armstrong. In this case, this should be in nanometers. The final answer you will always get in electron volt. So that is the logic for this. Okay. So if you know how to use this formula versus this, you are sorted for calculating energies. Clear, man? Okay. 200 plus possible in 2027? No, 2027 next year, 100%. Why not? Who says it is not possible? Obviously, it is possible, man. Hmm. When they can give you this tabular questions also. The following table gives the values of the work functions for few sensitive materials, sodium, potassium, molybdenum, etc. Work functions are given if each of them is exposed to 3300 nanometers, which of them will not exhibit photoelectrons. Because wavelength is given, so we know the energy of the photon. It will be, because this is nanometer, so 1240 by 3300. This will be in electron volt. How much is it coming out to be? 124 divided by 330. Come on, 124 divided by 330, guys. How much will it come out to be? How much is the energy of the photon? Yeah, 124 divided by 330. Yeah, come on. How much will it come out to be? It's almost like 3 times of it. So might be zero point 0.3, close to zero point 0.3 electron volt. Yeah, is that right? Yeah, correct. Till this point? Yeah. Now tell me, is the energy of the photon more than any of the work functions? No, right? Yeah. So if this is 3300 nanometers, do you think this will be more energetic than the work function? No. So this is less than all the work functions. Hence, no photoelectric effect will occur. Hence, no photoelectric effect will occur. Got it? Everyone? Everyone? Guys, please don't ask me counseling based questions now today. Guys, please mind it. What you are asking, where you are asking, how you are asking. I'm teaching for CBSE board today. I'm doing revision. Tomorrow is a physics board examination, and you are putting in the chat box, sir, I am this candidate, I am getting this percentile counseling question randomly. Think, man, think. Okay? Yeah. All right. Moving to the next, atoms. Let's go to atoms. So theory slides are there, which you'll be getting it as notes. Let's go to the first question on your screen. Two hydrogen atoms in the ground state collide inelastically. The maximum amount by which their kinetic energy is reduced by is how much? Okay, so the logic is as follows. You have hydrogen atom here and hydrogen atom here. They are both moving, let's say, opposite to each other, and they collide inelastically. Now, if they have to lose maximum amount of energy means what? Okay, yeah. Think logically. If they have to lose maximum energy means what? These hydrogen atoms would have had one electron which is revolving around them, right? One electron which is revolving around them. Now, they have to emit light. They have to emit light so that the collision becomes inelastic. So how can they emit light? Think about it. Maybe their electrons go to a high orbit. Because of the collision, the electrons get knocked out to a very high orbit, and after that they come back, jump back to the lowermost orbit. So imagine, just during the collision, they are in the highest excited state, highest excited state, highest excited state, and then they drop back to the ground state. They drop back to the ground state. In that process, they will emit photon, basically light is lost energy. This is the lost energy, isn't it? And that is the reason why the collision then becomes inelastic in nature. So highest excited state to the ground state, what is that energy difference going to be? That energy difference is going to be 13.6 electron volts, but there are two hydrogen atoms, so that's why 27.2 electron volts, which is option D, guys. That is the answer. Did you understand the process? The hydrogen atoms, they collide, the electrons get knocked out almost to the highest orbit, and when they jump back, they will emit light. Okay, and when they emit light, that light will have the energy difference of the highest and the lowest energies, which is 13.6 electron volt. Perfecto. Shall we go ahead then? Okay, cool. Let's move to the next question. The value of the impact parameter will be 0 when scattering angle is. So remember, if you have this as the nucleus, then the alpha particles are incident over here and they get deflected like this. So if this is the central line, then this becomes your impact parameter. This is your impact parameter, and this is the angle by which you deflect. If the impact parameter is large, then the alpha rays will go almost undeviated. So it's very obvious, if impact parameter is large, then the deflection is zero, negligible. But if the impact parameter is small, then you are going like a head-on collision. So the alpha ray from the nucleus will deflect back almost like 180 degrees. So the impact parameter, if it is zero, then the deflecting or scattering angle will be pi radian. That is the answer, guys. So both kind of questions can come. What will happen if impact parameter is large? Then the answer is the deflection or scattering angle will be zero. But if impact parameter is small, it will be like a head-on collision and it will get U-turned and it will deflect back by 180 degrees. Cool, everyone? Yeah, pakka, pakka, pakka. For semiconductor one shot, use this, man. Semiconductor. This is the best semiconductor lecture which you can get, guys. It's just for 2.5 hours properly if you want. All right, so you can definitely go ahead and complete it. And if you want to cover it in 1 hour, then I have done that also in 1 hour. You can check that lecture also. Okay, it was done just 3 months ago. And if you want one by one lecture, that is also there, but I wouldn't suggest this. I would suggest you guys to go with this or this lecture in case you want to complete the chapter, depending on the time that you have, man, till tomorrow. Okay, so use it wisely. Cool. Is that okay, Hemant? Moving on to the next question, number 4. It says, which of the following statements are true regarding Bohr's model of atom? Orbiting speed decreases as it shifts to discrete orbits away from the nucleus. Radius of allowed orbits of electron are inversely proportional to the principal quantum number. So if you remember, radius is R naught n square by z. So radius of the orbits is inversely proportional to the principal quantum number. No, rather it is directly proportional to the square of the principal quantum number. So B option is incorrect. Frequency and binding force increases as it shifts to outer orbits. Okay, so when an electron is revolving in that orbit, and this is that force, right? So that force is given by Coulomb's constant into nucleus charge into electron charge divided by r square. So as it shifts to outer orbits, r will increase, so the force will obviously decrease. So the binding force increases is wrong. It should actually decrease. So D option is also wrong. Speed of an electron, let's talk about it. Velocity is directly proportional to z divided by n. As it shifts to discrete orbits away from the nucleus, n will increase, so speed will reduce. So yes, the speed will reduce as it goes away. So yes, option A is correct. C also you can figure it out that it will be obviously wrong then. Okay, so if you use frequency, frequency is 1 by time period, time is circumference, which is 2 pi r by speed. If you see, yes, it will not come out to be true. Okay, is that clear, my dear warriors? Everyone, orbiting speed will reduce as you shift to the orbits away from the nucleus. So n increases, velocity will reduce, man. Velocity will reduce, not C option. I don't know why you guys said C. Be careful. Yeah. Did you guys get it? Why option A is correct? Yeah. Be careful, man. Be very, very careful. Okay. In hydrogen spectrum, the wavelength for H alpha is 656, whereas for the distant galaxy, H alpha is 706. Estimate the speed of the galaxy. Now, looking at the question, you will start wondering, sir, what is this question? How to solve this question? Galaxy, sir. What is this, sir? My mind blew away, sir. What nonsense, H alpha, what nonsense question is this? So I'll tell you, this is based on Doppler effect, but in light. Now, some of you might not know what Doppler effect is because it is deleted from the JEE syllabus and we are in NCERT syllabus. But it is deleted from sound, but not from light. That is the funny part. Now, it is there in NCERT, that formula, and let me explain what that is. It's basically whenever the source or the observer move relative to each other, the apparent frequency that you hear or see is different than the actual frequency. Like if there is a train coming towards you, then you will feel that the frequency which you are hearing is higher than what is emitted by the train's horn. But if the train is going away from you, the train is honking, the frequency heard by you is less than what the actual frequency is. So this is apparent shift of the frequency from the source due to relative motion between the detector and the source generating the light or the sound. So same logic is here. So in your regular hydrogen spectrum, this is the wavelength, stationary, like a train which is at rest has this much wavelength of sound, light, whatever, forget it. But a distant galaxy that is moving, so when the source is moving, relative motion is there, then your wavelength will also change. So the logic over here is delta lambda by lambda. Yeah, what is the formula, guys? Delta lambda by lambda is speed of that source relative upon speed of light. This is the formula. Understood? Clear? Awesome, awesome, awesome. I'll tell you everything, Jack, don't worry. Yeah. Sir, JEE has Doppler effect. JEE has JEE Advanced has Doppler effect. JEE Mains does not have Doppler effect of sound, but JEE Mains has Doppler effect of light. Okay, that's what I said. It is very funny. So delta lambda means 706 minus 656 upon original, which is 656, is speed upon 3 into 10 to the power 8. So calculate this value and tell me how much are you getting. Okay, into 3 into 10 to the power 8 is there. So 706 minus 656, correct? So this should be 50 and this should be 656. So check this out and tell me how much answer are you getting. Come on, my dear warriors. How much are you getting? Let me know quickly in the chat box. Come on. 10 to the power 7 will also come. Yes, 100% because this is 150, this is 656. So 150 and 656. So 15 goes with 650, almost more than 4 times, 5 times. So between 1 by 4 and 1 by 5. So it will be either 0.2 or 0.25 in between that. So it will be between 0.2 and 0.25. So that means 100% 0.2 will be there and 10 to the power 8 will be there. So therefore it should be 2 into 10 to the power 7. So 2 into 10 to the power 7 means option B, man. That is the right one. Just check this out. JEE Advanced Scholarship, but I still didn't get. You will get the information, man, in a week or two because yesterday only results came, no? So 2 days before. So it will take time, no, for us to also process, verify the results, then give the scholarships. So don't worry, man, you will get it. Yeah, B option. All right, moving on to the next one. Name the series of hydrogen spectrum lying in ultraviolet and visible region. Ultraviolet and visible region. Yes, come on. What is the one which is in ultraviolet and one which is in visible region? Lyman, Balmer, Paschen. Lyman is ultraviolet person. Lyman. Balmer, Balmer, Balmer is visible spectrum person. Visible spectrum person. Then Paschen, Pfund, etc. All these people, they are infrared people. Yeah, infrared people. Yeah, correct. So ultraviolet and visible. Ultraviolet is Lyman, visible is Balmer. That's it. As simple as that. Cool? Yeah. But if infrared is asked, then that will be Paschen, Pfund, Bracket, all these series, right? They are all in infrared region. Keep that in mind. Okay, perfecto. That is your simple 1 mark question, but you should know it. If you know it, you know it. If you don't know it, you lose that 1 mark. Simple. What is Bohr's quantization condition for angular momentum in second orbit? So you will write down the Bohr's angular momentum quantization is nh by 2 pi. But since you people asked second orbit, that's why I will substitute n as 2. So 2 into h by 2 pi, explain like a you are explaining a donkey or something. 2 will cancel, boss, and h by pi is the answer. So angular momentum is h by pi. Yeah, correct. So you have to explain. I have told you this yesterday also, as if you are explaining one small kid or one dumb person or one donkey. Okay. So, like how you will explain, like that only if you write down the answers, you will get full marks. That is what board people will expect. I never understood this. I had this ego when I was a JEE student because, this happens, especially with JEE students. Tell me if you also have it. And if you have it, put up a smiley in the chat box right away, right now. Or if you had it at some point of time. So, me, my friends, because we're preparing for JEE, toughest exam. But then that thing comes up because you are getting marks also in JEE. In the mock test, we slowly started scoring really good. We are using crazy methods. We are solving the questions with some tricks, with some nice formulas, with some nice concept, and then we are having fun while solving the JEE advanced questions. And that's when that ego comes when you're writing board paper. That, boss, why are you asking this? Then you start questioning, and go very deep into Indian education system. Why Indian education system is like this? Why they are asking me to write it like that? Oh, in JEE, they don't bother about these steps and all. They worry about the answer, and if I solve it using some innovative trick, that should matter. Why all this nonsense? Why this rote learning? So you get into that mode, then it is of no use. So you need to understand, you need those marks. Now it doesn't matter whether you want to do it by shortcut or not shortcut. Keep all those things aside. Okay, keep your ego aside. For your board exams, you want it, boss? Okay, here, lend the answer. You are a donkey. Think, okay, you are explaining to a donkey. Then you will feel very happy. I'm explaining to a donkey. Okay, you're explaining to a donkey. That should be the mindset. Correct? Oh, I can see a lot of smileys out there. Ooh, very good. Very good. Define Bohr radius. Very simple, no? 5.3 Armstrongs. Yeah, that's the Bohr's radius. That's the smallest radius of the hydrogen's electron in the ground state. That is called as the Bohr's radius. Yeah, perfect. First live. Copper Undevi Sivanandam 9411. Reading your name only, it will be like a marathon session, man. How many people are watching through your YouTube account? Hi. Yeah, both students feel bored. But there are some students who enjoy it. I remember in my class, there was a kid, not just a kid, many kids in my college sitting on the first bench, and they used to enjoy writing the definitions. I don't know what joy. How can anybody get joy writing a definition? I never understood that. Or writing whatever is there in the textbook, same thing, writing in the answer sheet. So much joy some kids used to get. And we never understood that. Okay. So that is what boards is. So don't get worried if your marks in boards are not up to the mark. because J is J at the end of the day. J is that king boss. That is that, you know, um, that has aura. Yeah, aura 999, you can say. Right. Right. Ooh. He means, ooh, Sanjit, Narayan, you like writing definitions? Shakti, you also write. So at least, oh, because of that, see, for marks, I understand, but somehow people get internal pressure writing definitions. So I do not get internal pleasure writing definitions. State the limitations of Bohr's model. Bohr's model had many limitations. So you should write like that. You should make yourself sound like you know more. State the limitations of Bohr's atomic model. Write it like that. Bohr's atomic model had many limitations. It's like you're doing a favor on that examiner. Boss, there are so many. Don't worry, I'm doing a favor by writing few of them. Here are a few. And then write down point 1, point 2, point 3. What? Number 1. First, Bohr's model failed even for even helium atom, like, or lithium atom, because the moment 2 electrons or 3 electrons come, it does not account for the repulsion. So it failed for multi-electron models. Number 1. Number 2, what else? What else? It failed somebody's theory. If I tell your position, I should not know the momentum. If I know momentum, I cannot tell you the position. Heisenberg's uncertainty principle. So it failed Heisenberg's uncertainty principle because it was able to predict the radius, that means the position, as well as velocity, meaning the momentum, together, which is impossible. So if always there is a probability of finding the electron, not the exact location. So it was not able to satisfy Heisenberg's uncertainty principle. Number 2, not 3. Yeah. Number 3, guys, there is a very weird effect called as, you should write it down, don't understand what it is. There is one famous dialogue I remember of Salman Khan. If you know who Salman Khan is, now it is a Hindi dialogue. If you don't mind, I can say that. He says in some random movie that Dil mein aata hu, samajh mein nahi. Okay, Dil mein aata hu, samajh mein nahi. That means I come in the heart. You can understand me in the heart, uh, but you will not understand me in the mind. Like, you cannot reason me out rationally. That is what the dialogue is. Same way, by heart this statement. Okay, dil mein aata hu, samajh mein nahi. Meaning, in Zeeman effect, if you use electromagnetic fields, then the atomic spectra lines begin to split. They begin to split. Atomic spectra, the lines are discrete. Tuck, 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 tuck. First transition, second transition, Lyman, Balmer, Bastian, first limit, second limit, third limit, series limit. All those lines are discrete. But when you use electromagnetic fields, then these lines begin to split. That is called your Zeeman effect. So that also he was not able to explain. Got it? Understood? Perfect. Awesome. Awesome. Hey, who is that? Bhaskar. Bro, you are going to get timed out. Yeah, don't spam. Moving on to the next one. It could not account for wave nature. That means Heisenberg's uncertainty. Distribution of electrons. That means multiple electron atoms. Okay. Calculate the kinetic energy and potential energy of an electron in the first orbit of hydrogen atom, guys. Come on, Laddu question. Everyone. Laddu question. What is the kinetic and potential energy? Now, kinetic energy is negative of total energy. So, total energy is minus 13.6 electron volt. So, kinetic energy is 13.6 electron volt. Okay, for first orbit, ground state. Yeah. What about next one, guys? Because tomorrow is exam. Sir, I can't understand you in mind because tomorrow is exam. No problem, Sanja. All right. Potential energy. Potential energy is 2 times of total energy. So, minus 13.6 is the total energy into 2, which is minus 27.2 electron volt. So, that is the answer for potential energy. That's it. Direct answer. Okay. What about this? The total energy of an electron in the first excited state is minus 3.4. Calculate the kinetic energy and potential energy. Which of the answer would change if zero or change if zero of potential energy is changed? Justify. I think third question, I'm not really sure, but the other two are simple. Kinetic energy is negative of total energy, so negative of minus 3.4 will be just 3.4 electron volt. Potential energy is 2 times of total energy, so it will be 2 times of minus 3.4. Am I writing 3.6? So this will be nothing but minus 6.8 electron volt. That is the potential energy. Is that right, my dear warriors? Very good. Yeah, these formulas you should know. Now, which of the answer would change if the zero of potential energy is changed? So zero of that means the zero reference. If the reference is changed, then which of these answers will change? See, when you change your reference energy, then only the potential energy will change. Potential energy will change. What you take as zero potential energy, if you change that definition of zero energy, then your potential energy will change. But kinetic energy, irrespective of the reference, kinetic energy will stay the same because speed, mass, half mv square will be the same. So kinetic energy will not change. Got it? Simple laddu question. Very good, man. Laddu, 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 laddu. Very good. Moving on then to the next one on your screen. Nucleus related theory, 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 theory. Okay, here is the first question. The volume of a nucleus is directly proportional to volume of a nucleus. Volume is 4 by 3 pi r cube. And what is the radius of a nucleus? It is r naught a raised to 1 by 3, so whole cube. So this will be 4 pi by 3 r naught cube into a. So the volume is directly proportional to a because a raised to 1 by 3 and raised to 3 will cancel. So a will be there. So option A for A, not D, man. Radius is proportional to a raised to 1 by 3. R cube will make that a's power as 1. Common mistake. That's what I'm telling. CBSE paper, you cannot make such random mistakes, man. The nucleus of which of the following pairs are isotone? Tone, iso. Isobar, isotope, isotone. Isotope means same atomic number. Isobar means same atomic mass number. Isotone means same neutron number. Same neutrons. That means A minus Z, which is N, this should be same. A minus Z, which is N, that should be the same. Come on, neutrons are same. Where is the neutron same? 74 minus 34, 71 minus 31. I can see it in the first one only, I think. Second one, no. Third one, I think by mistake this is printed wrong. I think. Oh, no, this is correct only. Sorry. That is also not correct. Even the D option is also not correct. Yeah. So 74 minus 34 is 71 minus 31, which is 40. So option A is the right answer. Very good, very good, very good, very good, very good. Moving on to the next one. A nucleus having same number of neutrons but different protons is called as isotones. I just told you. Isomers is organic chemistry. Isomers, that optical isomers. Isobars, same mass number. Isotopes, same atomic number. Okay, keep that in mind. Of this set which represents isotope, isobar and isotone respectively. Isotope, that means same Z. Same Z. It is here and here. This is possible. So B option is obviously eliminated. C is also eliminated. Then isobar means same atomic mass number. That I can see it here and here. So A option also gets eliminated. So it has to be D option. And you can see isotone this minus this and this minus this. So 197 minus 79 should be 198 minus 80. Correct. 100%. So this is also isotone. Perfect. D option. Awesome. 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 Next one. A nucleus represented by the symbol AXZ has how many protons, how many neutrons? Okay. Z is the number of protons and A minus Z is the neutrons. So option C is the right answer. Z is atomic number decided by the protons in the nucleus, positive charges. Neutral charges are mass number minus Z, the number of protons. C option, guys, not D. Some of you said C. Complete the following nuclear reaction. 4 beryllium 9 plus 1 H1 is 3 lithium 6 plus what? That 4 is here below. Come on, my dear warriors. What do you think is the right answer for this particular question? Always remember mass number should balance LHS and RHS. Same thing for Z also. So if you notice over here, 9 plus 1 is 10. 9 plus 1 is 10. So 6 is there. 6 plus what will be 10? 4 should be there. Next, beryllium 4 plus 1 is 5. Here 3 plus what should be there? 2. So what is 2 helium? Well, you can have helium over here. That is one option. Yeah. Or you can also have 2 times hydrogen. This is 2 and this is 1. This is also possible. Is that right, everyone? Yes. Yeah. Perfect. Similarly, let's go back to this one. Now here 10 and 4 is there. 10 plus 4 is 14. Here 13 is there. So only one thing is left. So number 1 will come. Number 1 will come. 13 plus 1 is 14. Boron 5, helium 2. 5 plus 2 is 7. So already 7 is there. So nothing can come. So 0. So charge wise 0, mass wise 1. So that is only possible for neutron. So neutron has a mass number of 1, but atomic number of 0. So only neutron can come out over here. Yes, that is the answer. That's how you detect the particle. Okay, perfect. Awesome. Next question, guys. A neutron is absorbed by 3 lithium nucleus with subsequent emission of alpha particle. Write the corresponding nuclear reaction. Come on, let's think about it. Now here they have given it in words. That's all. That's the main difference. Okay. So they have asked what will be the nuclear reaction. A neutron is absorbed. Neutron means N. Then there is 1. Then there is 0. Is absorbed by lithium. So lithium is there over here. 3. What is the atomic mass number of lithium, guys? What is the atomic mass number of lithium? Yeah, 6. Pakka. Okay. Shall we put? All right. Perfect. Is equal to what? Is emission of alpha particle. Now what is alpha particle? Alpha particle means helium. So if you want, I can just put alpha over here, and alpha particle means a mass number is 4, atomic number is 2. Now what else will be remaining? Think. Now 0 plus 3 is 3. So 2 plus what will give you 3? LHS, RHS should balance. Obviously, the thing which will balance is 1 over here. 1 plus 6 is 7. So 4 plus what will give you 7? 3 will give you 7. Is that right? So atomic mass number is 3. Atomic number is 1. So that can be only hydrogen. Hydrogen has atomic number of 1. Yes, but it is an isotope of hydrogen. It is an isotope of hydrogen. Is that clear? Pakka? Yeah, done. Very good. Atomic number is not 7, man. Atomic number is 3. So see, atomic mass number is here. 1 plus 6 is 7. So here also it should balance. So 4 plus 3 is 7. 0 plus 3 is 3. 2 plus 1 is 3. That's how it should balance. Below also and on the top. LHS and RHS. Okay. Perfecto. Right. Amazing, man. Amazing. Amazing. Shall we go ahead then to the next question? Oh, we are coming to semiconductors. Theories are there over here. Gates and in general theories. So let's start with some questions on your screen. Two PN junctions can be connected in series by three different methods as shown in the figure. If the potential difference in the junctions is the same, then the correct connection will be. Potential difference is the same, then what will be the correct connection? Either both are forward or one is forward, one is reverse. Yeah, makes sense. So in this, one is forward, one is reverse. Here both are forward, here both are reverse. So I think in 2 and 3. So 2 and 3 means B option. Is that correct? Because if both are forward, same diode, same drop will happen. If both are reverse, they will block the currents. The drop of whatever voltage is there will be equally divided between both of them. Yeah, B. Yeah. Okay. So let's move ahead. Yeah. Just ignore the gates notes from this. Yeah, just I'll delete it later on because gates is not there in the syllabus. Yeah. In comparison to half wave rectifier, the full wave rectifier gives, in comparison to half wave rectifier, the full wave rectifier gives lower efficiency, average output voltage, average DC, none of this. What do you think? Come on. What do you think? Yes, Aditya, just ignore that. Ignore that. Just one second. Yes, there is a batch which you can join for the April attempt, but that announcement will happen on 21st, 21st Feb. Vidya also, please be there. That event will be giving you that information. All right. Okay. Ice beer. Okay. Okay. So yeah, what is the answer, guys, for this particular question? Half wave rectifier, full wave rectifier is definitely more efficient. It will definitely give more average output voltage. It will give better DC. So answer is none of these only. Nothing great about it. This is not there. Ignore that. A solid which is not transparent to visible light, that means it is opaque, and whose conductivity increases with temperature is formed by ionic bonding, covalent bonding, van der Waals bonding. This is not needed. This is not there. Here. Here. But anyways, for that, the answer is covalent bonding, guys. Metallic ionic is not the answer. It's not van der Waals. It is covalent bonding. Basically, conductivity, if it is increasing with temperature, conductivity increases, temperature increases, resistance decreases. That is only a semiconductor, and a semiconductor device, like you can see, silicon, 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 not germanium, they form covalent bonds. They form covalent bonds. So it is anyways covalent bonding. Okay. It is very simple, but they have framed the question in a very crazy way. Anyways, moving on to the next question on your screen. Here it is. Give the ratio of the number of holes and the number of conducting electrons in an intrinsic semiconductor. What is the answer for this? Sigma match for the April attempt is there, man. It is there still. And Sigma students who have done well, they are already shifted to the Eklavya batch. Or if you have not yet declared your result, please declare and fill the forms. For you guys, if you have done well, it is free of cost depending on your percentiles, okay, or it's at a very good discount. I mean, if you are above 97, 96 to 100%, I think it is free of cost only, Ekalavya batch. So all the Sigma batch students are getting Ekalavya batch if you have done well in your JEE mains. Well, obviously, if you got 80%, no point preparing for advance. So that is why that barrier is there, okay. And your access for Sigma batch is there even till the April attempt. You can still attempt the test. Everything is there for your April attempt. Sigma batch access is there till the very end. So don't worry about it. Yeah, 1:1. NH will be equal to NE. Yeah, number of holes will be equal to number of electrons. So NH by NE will be 1 by 1. Yeah, it's an intrinsic semiconductors. Both will be equal. What type of impurities added to obtain N-type semiconductor? Answer is pentavalent. For P-type, it is trivalent. Pentavalent impurities like phosphorus, arsenic. Trivalent impurities like aluminum. Yeah, correct. That is added for making it extrinsic semiconductor. Draw PN junction in reverse bias. Which biasing will make the resistance of a PN junction very high? Obviously, reverse bias causes very low current called as leakage current. Forward bias gives very good current, which is less resistance. So reverse bias will be the answer. And PN junction in the reverse bias, obviously, you will connect P to negative and positive to N. So PPNN will be forward. P to negative, N to positive is reverse bias. Very less current will be there, and there is a big potential barrier which is being formed. There is a big depletion zone which cannot be overcome. So there is hardly any drift current which is there, which contributes to the total current. Correct. That is the answer for it. Next, what do you mean by depletion region and potential barrier in PN junction? So what do you mean by depletion region and potential barrier? So in that PN junction, you will see that there is a region where all the electrons got diffused from one side to the other side, from P side to N side or N side to P side. So because of which the electrons, they have left and gone, that is the depletion zone. And you will see that once the N side electrons go to the P side, N becomes positive, P becomes negatively charged. So this is at a lower voltage, low potential. This is at a high voltage. So there is a voltage difference between the P and the N. That voltage difference is called as the potential barrier. That voltage difference is called as the potential barrier. The electrons diffuse from N side to the P side. So the absence of that electrons depletes that semiconductor from those charge carriers. That is called as a depletion zone. So layer around the junction between the PN junctions where the charge carriers are less in number is called depletion region, because they have left that region. The potential difference created across the junction due to the diffusion of the charges is called as potential barrier. If you show these diagrams, it will be very useful. Yeah, it will be very useful. Okay, perfect. Moving on to the next question on your screen. In the following diagram, the diodes which are forward biased are, this kind of questions also come in JEE, so very straightforward. So this is 10, this is 5, this is in forward bias 100%, P to high, N to low potential. This is negative 10, this is 0. Negative 10 means lower potential, N is connected to higher potential, so this is reverse bias. This is minus 5, minus 12, so minus 5 is more than minus 12, so this is forward bias. Simple, because minus 5 means higher potential as compared to negative 12. Negative 12 is even lower than negative 5. So yes, so A and C is forward bias because P side potential is higher. All right, so that was the last question which we just did for all of you. All right, so all the very best. Take care. God bless you all. I'll try to share this PDF as soon as possible. Okay, God bless you. See you tomorrow, and do not worry so much. Please sleep well. Don't waste your time sleeping less. You will face the consequences tomorrow. Okay, bye bye. Take care.